Hey guys, welcome to the eighth video in the series where I'm explaining you how you can go ahead and find the range for any kind of functions that you can expect in your ES level syllabus. We have already looked into the straight lines, quadratic functions, square root, cubic, and in the last video we discussed about the reciprocal functions. And lastly, we are now going to discuss upon the trigonometric graphs. And in this video, I'm going to teach you entire graph knowledge that you need to know for the sine, cos, and tan graphs. And apart from that, if there are inclusions of transformation of the functions for each of the sine, cos, and tan, how we can do that. So yes, let's get started. So the first thing you need to know about the sine graphs is that the graph starts from the middle value. For example, this is a complete cycle of a sine x graph. Then of course the cycle can keep on repeating itself like this. And it can also repeat it on the backward side like this. So the sine x graph, if I show you, it's a sinusoidal pattern like you see over here. Okay, you can see this kind of a waving pattern, and a complete cycle is over here. This is your complete cycle, and then this cycle repeats on the left hand side and also on the right hand side forever until you restrict some kind of a domain. Let's say if I'm planning to restrict the domain in between 0 to 2 pi, that is 0 to 360 degrees, I can do that. Simply write pi for pi, and you can see that there is only one cycle that is over here. Okay, so sin x, as you can see, is a continuous graph forever. There is no limitations on the x values that it can take as an input until and unless you restrict your domain values. That is one important point to keep in mind. So the first thing is the graph will always start from the middle value, and then it can go to the maximum, then again come to the middle value, then the minimum, then the middle value. Or else it can start from the middle value, then go to the minimum value, then the middle value, then the maximum value, and then the middle value. Okay, how do we know if it's this kind of a shape or it's this kind of a shape? If your sign is a positive sign, okay, if it's, let's say, sign of some kind of x, 2x, 3x, whatever, but if the sign itself is positive, the graph is like this. It is first going to go from middle to maximum, and then this kind of pattern just repeats: middle, maximum, middle, minimum, middle, maximum, middle, minimum, middle, maximum. That kind of a pattern will keep on repeating itself after every fixed interval of 90 degrees or pi by 2 radians. Okay, I'm going to show that to you in a couple of seconds. And if your sign is having a negative sign outside as a coefficient, in that case, it does not go from middle to maximum, rather it goes from middle to minimum. And then again, it will repeat the cycle. So after middle, there is a minimum. After minimum, there can't be anything less than minimum value. So it goes again back to the middle, then maximum, middle, then minima, middle, maximum, middle, minimum, middle, maximum, middle. That kind of graph will keep on repeating itself. So if I just add a negative sign outside, you can see that the graph is just flipping like this. And then if I remove the domain, and the graph will just continue. This kind of a pattern will keep on repeating itself on both the sides. You can see that. So that is the first point to keep in mind about how the graph looks like. Now, what is the maximum value of the output of the sin x? I'm not talking about the x value, okay? I'm talking about what is the maximum output a sin x can give. So the maximum output, as you can see, this value is 1. Everywhere you can see that it is 1. Don't look at the x value, I'm talking about the y value. So we know that the entire sin x can take a maximum value of 1. What is the minimum value it can take? As you can see everywhere, it is -1. So -1 is the minimum value your sin x can take. What is the average or the middle value of this 1 and -1? If you take the midpoint of 1 and -1, of course it is at 0. So this is your middle value. All the y values over here will be at 0, as you can see. So all the points I have mentioned over here, and it's going to help us a lot finding the range of the trigonometric questions as we go ahead. Okay. And the fixed interval, as I mentioned, that if you go from middle to maximum, then maximum to middle, then middle to minimum, minimum to middle, all this kind of interval, all this kind of intervals for the sin x graph, happens at 90 degrees or pi by 2 radians. If let's say if you're having, let's say, not sin x, but if you're having sin 2x, in that case the fixed interval will change. This is only the data that I've written over here is only for the sin x curve. What to do when you are having a multiple of the angle x, let's say if it's 2x, half x, 3x, in that case is what to do. I'll talk about that in a couple of minutes. But for now, if I go to the Desmos, you can see that the graph that we have plotted over here is only to help you understand the graph is forever. There is no end to the graph. The cycle keeps on going forever. Okay. But in your AS level examinations, usually the graphs that they'll give you, they will always have certain kind of a domain. Let's say 0 to 360, 0 to 180, 0 to 90, or minus 90 to 90, minus 180 to 180. That kind of graphs will be asked for you to sketch or maybe utilize that graph to find some kind of answer from it. Okay. Now, one important thing before I go ahead and show you the graphs, you just come to Desmos and go to the graph settings on the top right. If you want to deal with the radians, you can keep in the radians mode, but I want to deal with degrees. And let's say I'm going to say that my x-axis goes from minus 360 to 360. This is just so that the graph is fitting properly the values that we want to see. And the step over here, I'm just going to change it to 90 degrees. And now you can see that, for example, if I'm having a positive sin x graph, my positive sin x graph starts from the middle value and then it goes to the maximum value after 90 degrees. Then after another 90 degrees, it goes from maximum to the middle value, right? From middle, it went to maximum. From maximum, it came to middle value. After middle value, it won't go up, it will go down. It has to follow this kind of a pattern, a wavy pattern. So after this, at 270, if you do 180 plus 90, you get 270. So at 270, you get a minimum value of the sin x, which is minus 1. Remember, I mentioned all these values over here. Middle value is 0, minimum is minus 1, maximum is positive 1. And then again from the minimum, it goes to the middle value of 0. And after every 90 degrees, this shift is happening. This is very important for us to keep in mind. Now let's say if I want to deal with the radians mode, in that case, I'll just change the step to pi by 2. Okay, and hit enter. And over here also, I'll just change this to, let's say, minus 2 pi to 2 pi. And now it looks good, right? Even though the domain keeps on going forever, this is just to adjust your x values or the x axis of the Desmos. That's it. Okay. And why am I showing all this to you? So that when you're practicing the graphs by yourself for the trigonometry, you know how to change the settings so that the graph looks similar to what I'm going to teach you in your trigonometric graphs over here. So we are having the function sin x, for which we have to find the range in between this domain 0 to 180 degrees. So the first thing would be to draw the axis depending on the domain. Because I'm starting from 0 degrees, that is why I'm plotting like this. If I was starting with a negative angle, I would have gone like this, because I also need to include the negative angles along with the positive angles, right? But for now, because I'm starting from 0, I guess this is enough. So over here, I'm going to say that I'm first going to mark my values that are maximum of the sin x, the middle value for the sin x, and the minimum value for the sin x. And then I'm also going to write the x value. So I know that it starts from 0. And after that, after every fixed interval of 90 degrees, it will go from 0 to 1, 1 to 0, 0 to minus 1, right? The middle, maximum, middle, minimum, middle, that kind of thing will follow because there is a plus sin x. If it was a negative sin x, my graph would have gone from 0 to minus 1 to 0, 0 to 1, and then 1 to 0. That is the pattern that we know. But yeah, because it's a plus sin x, the graph will go on the top position. So after every 90 degrees, this happens and the domain goes till 180. So I know that my graph is going to be something in between 0 to 180 degrees. And the shape of the graph is going to be like this, where the maximum value a sin x can take is 1. I know that. And the graph does not continue after 180 degrees because, of course, the domain is limited to 180 degrees. In this case, what is the range? How do I find out the range by looking at the graph? Of course, I need to know what is the minimum output the graph is going to take and what is the maximum output. So maximum output clearly is a value of 1 and the minimum value is 0. Between this 0 and 1, you can see that all of the values, wherever you point, you will get the outputs in between 0 to 1, right? So basically you can say that over here that the range for the function is 0 to 1. And you can see that I've also included 0 and 1 both as the part of your answer, because the 0 value is included on the minimum possible value because 0 and 180 both are part of the domain. And 1 is also included in the range because 90, which gave you 1, is also part of the domain. So that is how you do this question. And I have also plotted the graph on the Desmos for the sin x for the given domain. And clearly, as you can see, that it is satisfying the graph that we had drawn. And the output is only in between 0 to 1. There are no outputs below 0 or no outputs above 1. And that is why the range is in between 0 to 1. Now, moving on to the second question. We are given this kind of a function minus 2 sin x plus 3. In this case, what are we supposed to do? The first thing that you will do is you are going to identify what are the maximum, minimum, and the middle values for the entire function. How can you do this very easily? Simply substitute the maximum, middle, and minimum values for the sin x over here. So minus 2 into 0 plus 3. Then you can do minus 2 into minus 1 plus 3. You can do minus 2 into 1 plus 3. Now, whatever are the outputs over here that you are going to get, whatever outputs you're going to get. So over here, I'll be getting 3 minus 2, 1. Over here, I'll be getting 3 plus 2, which is 5. And over here, I'm going to get 3. For the middle value, what is the other technique? Of course, you can take the midpoint of these two values. 5 plus 1 is 6, 6 by 2 is 3. Even that is possible. Whatever suits you the best, you can use that. So in this case, as you can see that this is our maximum value, this is our minimum value, and this is our middle value. So what you do, you just create the axis with the maximum value at 5, minimum at 1, and middle value at 3. And after that, just follow the pattern starting from the middle value. Then because it's a negative graph, this time you're going to go from middle value to the minimum value, then minimum to the middle value, middle to maximum, and this kind of a pattern will keep on following. And of course, you need to keep in mind what is the domain for which you are plotting it. So in this case, I'm plotting in between minus 360 to 0. It means I am on my negative domain. So this is the summary, but let me take you through entire process step by step. So the first thing I'm going to do is I'm going to write the values for my y maximum. So I know that the y maximum came out to be 5 when this was minus 1. So minus 2 minus 1 plus 3 is equal to 5. Then y minimum was when sin x was 1. So minus 2 into 1 plus 3 is equal to 1. And of course, the y average value or the middle value, let me write it over here. Y middle value came out to be 5 plus 1 by 2 is equal to 3. Or else you can also do minus 2 into 0 plus 3 when that is going to work. And now I'm going to draw my axis over here in the negative direction because there are no positive values it is taking. And of course, there are no negative outputs also. So it's better that I draw my graph over here like this. It makes sense, right? Again, you don't need to be perfect. Just draw however it is able to recognizable for your case. Okay. No one else needs to understand what you have done over here. So 5, 3, 1. And I can just draw a dotted line so that I can know that this is my middle value. Now please note that the graph that we are going to start, we know that it starts from the middle value. And then for a negative sin x graph, it doesn't go from the top, middle, bottom. It goes from the middle to the minimum, then from minimum to the middle, then maximum, middle. Like this, the graph goes. But this is for the positive domain. In our case, we are having a negative domain. So in this case, you are just going to repeat the cycle on the left side. So of course, it cannot go down like this because the cycle will break. So it must go to the maximum, then the middle, then the minimum, then again middle. So this kind of a graph will be following. So it's very important for you to identify that the graph will go in the negative direction. Will it go in the minimum way or it will go in the maximum way? So you can easily identify this just by imagining what is the graph on the right hand side on the positive domain, and then just keep on continuing the cycle on the left hand side. That is the trick. So what I'm going to do over here is I'm going to say that at 0, it is at middle value. Then we are having minus 90 degrees, then minus 180 degrees, then minus 270 degrees, and then at the end, minus 360 degrees. Please note all the gap that I have written over here are 90 degrees apart. So from 3, it's going to go to the maximum value at 5, then middle value, then minimum value, then a middle value. I'm simply going to connect them now. So that is how the graph is going to look like approximately. Clearly over here you can see that the minimum y value is -1 and the maximum y value is 5. All the outputs are lying in between 1 to 5, and therefore what will be your range? Your range over here will be in between 1 to 5. This becomes your answer. So I've also plotted the graph on the decimals. As you can see, y equal to 3 is the middle value. The dotted line that you are seeing is coming from this part. And for both the cases, I have kept the domain from -360 to 0 so that we can mimic the graph that we had drawn over here for this question. And clearly we can see that the minimum value is 1 and the maximum value is 5. So from 1 to 5 becomes your range. All the outputs will be in between 1 to 5. Now I'll tell you a trick for which 99% of the questions you can do it without the graph also. So what is the trick? If your domain includes at least one cycle, if your domain includes at least one cycle, your answer will always be going from y minimum, whatever value that you calculated, to y maximum. No doubt about it. And in certain kind of cases where the domain does not include a complete cycle like what you can see over here, a complete cycle would have been like this. But yeah, when your domain is not allowing a complete cycle to take place in the graph, in those cases 100% you will have to sketch the graph and then identify what is the minimum and the maximum value. It won't take more than 30-40 seconds to draw even very difficult kind of a graph. But yeah, this kind of questions are pretty rarely asked. In most of the cases you will see that at least one cycle is present and therefore you can go from minimum to maximum. So let's say in the examination, if we are stuck into a particular question and it has taken a lot of time, and there is also a question on the range for the trigonometric graphs for the sine and cos. Okay, the trick that I told you is only for the sine and cos, not for the tan. I'll talk about the tan later on. For now, focus on the sine and cos. In sine and cos, both y minimum to y maximum will apply if your domain is allowing your graph to have at least one cycle. Okay, but yeah, now we can go and talk about the next question. So a function of sine 2x is given to us and we are supposed to find the range in between 0 to 360 degrees. Now please notice that there is no y transformation in this case, only x transformation is there. We know that this is a squeeze of the graph and the stretch factor, if you want, is 1 by 2. All the x values are going to be reduced to half. That is what we know. Unlike the previous question, in the previous question we saw that there was no transformation in the x-axis. There was only the stretch factor of -2 and the translation of +3 happening in the y-axis. But in this case, no matter whatever is the input value, whatever, if there is nothing happening outside of the function, there is no changes in the maximum, minimum, or the middle values of the sin x. So even if I'm having, let's say, sine of whatever I can think of, the output will always be maximum at 1, minimum at -1, and middle at 0. No matter whatever is your input, 2x, 3x, half x, 2x plus 90, whatever. My output values will not differ from 1, -1, and 0 for maximum, minimum, and middle value respectively, because there is no transformation happening in the y-axis. The only thing that is going to be impacted is the x value. So let me show you how you can draw the graph over here. The technique that I'm going to show you will focus in a way that even the difficult graphs you can draw very comfortably. It will be slightly time consuming as compared to, like, very easy techniques out there which only works on certain cases, not on all the cases. But yeah, I guarantee that if you stick to the method that I'm going to teach you, all the questions you will be able to solve very easily. Okay, it may be slightly time consuming, I accept that, but this method works universally. And I have been following this for multiple years, and I have also taught this to multiple students, and all of them find this technique very easy and helpful in their examinations. So let me teach that to you. The first thing that you're going to do is you're just going to write your 0 degrees and 90 degrees. And then these are the values that we always plot to start with. But now in this case, because of this 2x, I know that there is a division of 2 for all of these x values that we plot. X by 2 has happened, x by 2 has happened. I'm just going to See what is the change of 0 degrees and 90 degrees to find the fixed interval. Fixed interval will now not be at 90 degrees. It will change. So 0 degrees, if I do 0 by 2, I get 0 degrees. And if I do 90 degrees by 2, that will be 45 degrees. So now what is the fixed interval? The fixed interval is 45 degrees. So 45 degrees is fixed interval. Please know over here, finding the fixed interval is important, and then the cycle will repeat on the same thing. Just know that this is your new starting value. This is your new starting value. Of course, the fixed interval now is clear to you. It's 45 degrees. So how am I going to plot this? All right, guys, don't get scared. What happened? There is a cut in the video. Actually, I had gone a lot far ahead in the video, but then I realized that there was a mistake in the graph that I had drawn over here. So I'm just coming back over here and fixing that part. Okay. So of course, the minimum and the maximum value for the sine 2x would be -1 and 1, and the middle value at 0. But now I'm going to write the intervals at 45 degrees. So after 0, it will be 45 degrees. After 45, it will be 90 degrees. After 90, it will be 135. And after 135, it will be, I guess, 270. And that is where I had done the problem actually in the video. So what is 135 plus 45? It is 180 degrees. And 180 plus 45 is 225. Okay. So 180, then 225, then 270, then 315. I'll again check this. So after 270 is 315, after 315 it is 360. Yes, now this is good. So as you can see that this kind of questions are very rarely asked, but I'm just giving you a practice over here so that no matter whatever is the difficulty of the question, you can still sketch your graphs. Okay. But yeah, please use your calci properly. Do 45 plus 45, 90 plus 45, 135, so on and so forth. Okay. And don't be like me in a hurry. Don't mess it up. Now I know that after every fixed intervals, you're going to go from starting value to the maximum, maximum to the middle value to the minimum, and that kind of a pattern will keep on repeating itself. And given that the sin x coefficient is positive, I'm going to start from the middle value and then move on to the maximum value at 45 degrees. And then after another 45 degrees, it will be at middle -1, middle, that is my one complete cycle. Now from middle again, it will go to the maximum, middle, minimum, and then again middle. And that is the graph that I have drawn over here. And my answer my answer over here will be going from -1 to 1. That will be the range. Now let's say if we are not supposed to draw the graph, and if we are supposed to do it just like if minimum to maximum will be the range. I told you that if in your domain there is one complete cycle, at least one complete cycle, then of course it will go from minimum to the maximum. So this number over here that you are saying is actually your how many cycles will be fitting in 0 to 360 degrees. So there are two cycles. So of course, because you are going beyond one cycle, even without drawing the graph, you could have said that the range over here will be -1 f of x to 1. Okay, you could have directly said this as your answer. And I have also plotted this on the Desmos, sine 2x from 0 to 360 degrees. You can skip this part. And again, you can see that there are two complete waves and the minimum value is at -1, maximum is at 1. So the range lies in between -1 to 1. Now I'll continue from this question. So again, don't be scared. So over here, I'm going to be done with the editing part. So yeah, enjoy the next part of the video. So here is a new question in front of us, that is to find the range in between 0 to 180 degrees for the function 2 sine half x plus 1. Now, as you can see that there is x transformation given to us. Along with that, we are also having y transformation. So whatever we did over here for the y transformation and whatever we did over here for the x transformation, both things needs to be compiled over here to find the answer. Now, let's see if I have to apply the shortcut technique, find the minimum and maximum value like what we did over here, and then say that that is the range. Is that going to work? As I mentioned, if your graph can include one complete cycle, for sure that will be your answer. Or else you will have to sketch the graph, or at least imagine the minimum and the maximum value. So in this case, what I'll do is, I know that in 0 to 360 degrees, I'll only get a half wave. In 0 to 360 degrees, my graph is going to look like this. So in 0 to 180 degrees, my graph is only going to look like this. This is the idea that I already know. So it means that from the middle value to the maximum value, that will be my range. Directly, I can do it like this. But now let's say if I have to draw my graph, and from the graph, I have to identify the range. How will I do it? So what is my y maximum value? Let me check. My y maximum will be 2 times 1, because of course the maximum value of the entire sine of half x, no matter whatever is the input, will be 1. So 2 times 1 is 2, 2 plus 1 is 3. So that is 3. My y minimum will be 2 times minus 1, which is minus 2. Minus 2 plus 1 is minus 1. Then y mid, you can do 2 times 0 plus 1, which is 1. And for the values on the x-axis, 0 will change to what? Now this is multiplied by 2, right? It's a stretch factor of 2x. So it will become still 0, and 90 degrees is going to change to what? 180 degrees. So the fixed interval is 180 degrees. That is what we understood. And this is your starting value. This is your starting value. Let me write it properly. Starting value. Okay. Fi means fixed interval that I've written over here. So I'm going to sketch the graph from 0 all the way up to 180 degrees. And there is only a gap of 180 degrees. So there are only two values that I need to show. And the values are going from minus 1 to 3. So let's say this is your minus 1. Let's say this is your 3. And the middle value is somewhere over here 1. I can draw a dotted line over here if I like. And the graph is going to start from the middle value, as we know, that is the sine x graph. And the x value, starting value is 0 degrees. So that is where I marked the first point. And at 180 degrees, it will be at maximum. So from middle to maximum, that will be the graph that we have to plot. Simple as that. That is the graph, and the range, as I also told you, without drawing the graph, it will go from middle to maximum value. So over here, you can say that the range will be in between 1 to 3. And I can also confirm this from the Desmos. Let me go ahead and plot the graph for you. So 2 sine half x plus 1, 2 sine half x plus 1, and 0 to 180 is what we have to plot. And I'll also draw the mid value at 1, y is equal to 1, and copy paste the domain and just turn this to a dotted line just to make it look better. And clearly you can see that the minimum value is 1 in this case. I mean, for the range, the minimum value is 1. This is a mid value of the entire graph, which is looking like a minimum value over here. And the maximum value it can go till is 3. So 1 to 3 becomes your range over here, and that we are confirming from the Desmos also. So yes, guys, that was the discussion with respect to the sin x graph. And please know that there will be a lot of questions in the past papers where you are supposed to draw the sin x graph, cos x graph, or the tan x graph. So it's good that you practice the graph while you are finding the range. It will also boost your imagination that even without the graph, we are supposed to find the range. You can do something like what I had done over here for this question, that okay, there is a half cycle in between 0 to 360 degrees. So 0 to 180 degrees will just have this much of the cycle. So that is the middle value, that is the maximum value. So in between middle to maximum. So you will be able to do this kind of things very easily and comfortably if you have done enough practice of the graph like what I have shown you over here. So please don't skip any kind of practice of the trigonometric graphs. And now you also have the Desmos. Get any random kind of equation and try to plot and see what kind of outputs you get. Compare it with the Desmos. If you are struggling, you can leave a comment on this video. I'll surely go ahead and help you out with that. But yeah, this was the discussion with respect to the sin x graph. Now it's time to move on towards the cos x graph. So the cos x graph is very similar to the sin x graph. That means that the cos x graph has a maximum at 1, minimum at -1, and the middle value at 0. And after every fixed interval of 90 degrees or pi by 2 radians, you can go from maximum, middle, minimum, middle, maximum. That kind of a pattern can be observed. The only difference that you are seeing over here is that instead of the graph starting from middle value and then it goes either to the maximum or the minimum, the graph will now either start from the maximum value, then go to the middle value, then the minimum, then the middle value, and then again back to the maximum, or it will start from the minimum value, then go to the middle value, then go to the maximum, then from the maximum it goes to the middle, and then again come back to the minimum value. So this kind of a pattern will be there. Just know that the starting value over here for the y-axis will be either the maximum or the minimum value. So if the coefficient of the cos is positive, it will start from the maximum value. If the coefficient of cos is negative, it will start from the minimum value. That is the only one thing that is different. Everything else, the transformation and everything else that we have seen over here will be applied as it is for the cos x graph. So let us look into our first question. So we are given the function minus 2 cos x minus 1 for which we have to find the range in between this domain minus 180 to 180 degrees. So in this case, what are we supposed to do? As always, find the y maximum value. In this case, how will you find the y maximum value? Just do minus 2 and then cos x will be minus 1 so that this becomes positive to give you a maximum value minus 1. For y minimum value, what are you going to do? Y minimum will be minus 2 into 1 plus 1. Minus 1. So this is your 2 minus 1, which is 1. This is your minus 2 minus 1, which is your minus 3. So what is your middle value? Your middle value will be cos x is 0. That is the middle value. So minus 1, right? Or you can do minus 3 plus 1 minus 2 by 2. That is minus 1. And there is no changes in the x-axis. It means that it will go from 0, 90, so on and so forth. Or also in the left side, 0, minus 90, minus 180, so on and so forth. And because the cos x graph is having a negative coefficient, it means that the graph is going to start from negative value or the minimum value. Then it goes to the middle, maximum, middle, minimum. That kind of a graph structure we'll be able to see. So let's try to plot the graph very quickly over here for us. I just draw it a bit in the center like this. And I just draw this slightly upwards because the minimum is going till minus 3. So 0, then 90 degrees, then 180 degrees. Similarly, minus 90 degree and minus 180 degree. After that, you can plot the maximum value is 1, middle value is minus 1, and the minimum value is minus 3. You can draw a dotted line over here for the middle value. Please ignore the background if there is a disturbance. And over here, if I am supposed to plot the graph, how will I do it? I'll start from 0 because that is my starting point, and it starts at minimum value because of the negative coefficient of the cos, and on the right hand side we'll go to the middle and then maximum. On the left hand side, of course, I can continue the graph in the same pattern because my graph on the right hand is going to be like this. On the left hand side it should be like this. So from minimum it will go to a middle value, then a maximum value, and now I just need to connect the dots, and that will be my graph over here. So if I try to do that, it's going to be something like this. So clearly the range goes from the minimum to the maximum value. As you can see that the complete cycle is included of the graph. So the minus, I should say the from minimum to maximum is your range. So even without the graph, if you had identified that the graph is going to look like this, which is slightly difficult for the domains, which is not very obviously in between 0 to 360 degrees. But the general idea is that if your domain accounts for at least 360 degrees, that is if you do 180 minus minus 180, if the answer is at least 360 degrees, it means one complete cycle has already been fixed. You can think about that when there is just a normal x. And if there is a complication over here, if there is a transformation in the x-axis, then of course it becomes a bit complicated. And that is why it's always good that you are able to sketch the graphs, and on the spot you are able to see the range going from minus 3 to 1. So the answer over here that you can write is range is going to go from minus 3 less than equal to f of x less than equal to 1. That will be the answer. Let's confirm it from the Desmos. Minus 2 cos x minus 1 minus 2 cos x minus 1, and the domain is minus 180 to 180. The middle value is now at minus 1, and the domain again minus 180 to 180. And that is the graph that we had also got over here. The maximum value it can take is 1, as you can see. The minimum value is minus 3, and that is why the range is going from minus 3 to 1. That are the output values that are possible. I hope this question is clear to you. Moving on to the next question now. We are given cos of minus 2x plus 1, for which we have to find the range in between 0 to 360 degrees. One important thing over here, which is unusual as compared to the previous question, is the negative sign over here. This negative sign is basically a reflection in the x-axis. So the graph that you are having on the right side of your y-axis will be now reflected on this side, and the graph that you had over here will be reflected on that side. So what is the best way to sketch a graph like this? Because you know that the domain is 0 to 360, what you do is you draw the graph for minus 360 to 0. Once you know how the graph is going to look over here in between this, you can just create the replica of exactly the same thing on the right hand side. And let's say if you are just supposed to find the range, the graph is not necessary for that. And over here, there are two complete cycles in between 0 to 360 degrees. And we know that if there is at least one cycle in between 0 to 360 degrees, then the answer will always go from y minimum to y maximum. Whatever is the y minimum and y maximum of this entire function, that will be a range. But let's say if we are supposed to plot the graph, how we can do that? So clearly my x values are going to go in a different fixed intervals, not 90 because of a stretch factor of half. So let's see what is happening to that fixed interval. 0 is going to become 0 only after a half x, and 90 is going to become, I guess, 45, right? After x by 2, it will become 45. And your fixed interval therefore becomes 45 degrees. So after every 45 degrees, we will have to plot the graph, and the graph will go from, it will start from the maximum. So from maximum, then it will go to the middle value, then the minimum, middle, maximum. And on the left side, if I'm drawing, it will continue the same pattern. Middle, minimum, middle, maximum, middle, minimum. That kind of a pattern will be there. So if I'm drawing my graph over here, I also need to find what is my y maximum, y minimum. So my y maximum will be when my entire cos x graph, because whatever is the input, we don't care, right? Because there is no transformation in the y axis alone for the cos x. So the maximum value of the cos is at 1. So 1 plus 1 is 2. So I can write 1 plus 1 is equal to 2. Y minimum will be at minus 1 plus 1, which is 0. And y middle value will be at 0 plus 1, which is equal to 1. So if I have to plot the graph, it will be going from 0 to 2, middle value is at 1. And the starting point will be at the maximum because of the positive coefficient of the cos. And the graph will have two complete cycles. So it will go like this, one cycle and then second cycle. And the reflection is what I have to draw now in between 0 to 360. Exactly the same graph on the right hand side like this. One cycle, two cycle. That's it. And clearly you can see that the range is going from 0 to 2. You don't even need to sketch the graph for the range. But as you know, I am a big fan of drawing the graphs. So here you go. So I'll just include the negative part also, just for your sake of understanding that I had done something like this before the actual graph. So minus 360, 0. Over here there is 2, over here there is 1, a dotted reference line. And then there are two cycles, one cycle, and then second cycle like this. Oops, one cycle, second cycle. So we're just going to draw the reflection. I'm going to write it like this, that this is my reflection. So my final graph is going to look something like this. So 0 degrees, then 90 degrees, then 0, then 45 degrees because the fixed interval is 45 now. Then 90 degrees, then 135 degrees, after 135, 180 degrees, then 225 degrees. I hope this is correct. 225, 270, then 315, and then 360. The minimum is 0, maximum is 2, middle value is 1. And because we are drawing the reflection, the graph is just going from maximum, middle, minimum, middle, maximum, middle, minimum, middle, like that. So from middle, we are going to, I mean, maximum, we are going to middle, minimum, middle, maximum, middle, minimum, middle, maximum. Again, the graph is just because you might be asked to draw the graph in the final examination. We don't know. But I've already told you the shortcut trick how you can do it. So that's the graph for this one. And the range is in between 0 to 2. That is the answer over here. I can show this to you on the Desmos. The question was cos of minus 2x plus 1. So cos of minus 2x plus 1, and the domain is 0 to 360 degrees. And yeah, that's it. This is the graph. You can draw y is equal to 1 for the middle line if you like, and convert this to a dotted. So yeah, 1 cycle and 2 cycle. This is exactly what we had got. The maximum value must be at 2, minimum value must be at 0. So yeah, range is going from all the way from 0 to 2. That is the answer for this question. So for the next question, the function is minus 2 cos of 1 by 3x plus 1, and we need to find the range in this domain. Now in just 360 degrees, we know that there is only 1/3 of the cycle. One cycle is not completed. So let's say if you find the y minimum over here, y maximum, so y minimum will be minus 2, minus 1, or I would write plus 1 over here because it's a minus 2. So this is how I'll be getting a minimum value. So the minimum value is minus 2 plus 1 minus 1. What is my maximum value? Y max is minus 2 minus 1 plus 1. So plus 2 plus 1 is 3. And of course, my y average or the y middle value is 1. And now if you say that the range is going to go from the minimum value to the maximum value, it might not be true because the graph does not cover at least one cycle in 360 degrees. So in this kind of scenarios, it is always better to sketch the graph. So let's try to do that. But for that, I'll also need to check what is the new value of the fixed interval. So 0 is now a stretch factor of 3 is still going to be 0. Then 90 degrees. So 90 into 3 is 270 degrees. So that is the kind of an idea that we are having over here. So the fixed interval is 270 degrees. And now let's say if you have to sketch the graph, uh, this is how I'm going to draw my axis. Minus 1, then middle value is at 1, and the maximum is at 3. So a dotted line at 1 is going to look good. And the cos x is having a negative sign, so I know that the starting value is still at 0. Starting value. So at 0, I'm going to start. The next value after 0 that I'm going to write is directly 270. And on the left side, of course, minus 270. So 180 is going to come somewhere in between. So I'll just use my calc and find what is the output at 180 degrees. So I'm using my calc which you can't see, but minus 2 cos of 180 by 3 plus 1. The calc is giving me the answer of 0. So at 180, let's say if 180 is over here, I will stop at 0. That is the main conclusion. Now I have to draw the graph. Because the cos is having a negative coefficient, I'll start from the minimum value at 0 degrees. And then at 270, it will be at middle value. And at 180, it will be 0. So something like this, the graph is going to look like for this. So clearly, the range is not going from minus 1 to 3. It is only going from minus 1, and the maximum value of the y is 1 in this case. So minus 1 to 1 is the range that you are going to get over here. Okay, the minimum value is this, and the maximum value is this. Everything else is always in between -1 to 1. So I'm just going to write that my range is in between -1 f of x to 1. That's it. This will be my answer. I'm just going to mark it over here. I can also show this to you on the Desmos. -2 cos 1 by 3x plus 1. It's always good to check it on the Desmos just in case if you have done any kind of a mistake. You can spot it over here. Simple as that. The domain was -180 to 270. Okay. All these questions are self-made. Okay. You won't get any difficult question as compared to this. The middle value was 1. Of course, the domain I'll need to change it so that it looks good. So yeah, the minimum value is at -1 and the maximum value it can take is 1. So -1 to 1 is your range. And the graph is again just like we had expected from 0 to -1 all the way up to 1. Right? 0, -1 all the way up to 1. So because the graph did not have at least a complete cycle, one complete cycle, that is why the graph was mandatory in this case. So I hope that this question is helpful for you to understand a lot of different kind of concepts altogether. Moving on to the next question. So in this question, we are supposed to find the range of this function in between 0 to 2 pi. Now all the questions we have done so far was in degrees. Now let me also do it one in your radians mode. For that I'll also change my Desmos from degrees to radians and I'll just change this to pi by 2 so that it looks good on the screen over here. And coming back over here, see in 0 to 2 pi there will be one complete cycle, that is for sure, in 0 to 2 pi. But then there is a minus pi by 4 in this case. Okay, so the whole graph is shifted pi by 4, that is 45 degrees to the right hand side. That is what it means. A complete cycle is shifted to the right hand side for 45 degrees. So in this case, let's say if my cos x graph looks like this, and if I shift my entire graph to the right side by 1 unit, I mean 45 units. So let's say 45 extra is still here because of course this is your -90. So this part of the graph is your one complete cycle. So yes, the maximum and minimum both is going to be included over here. So whatever is the new maximum and the minimum, you can clearly see that it can included in the range. It could be included in the range. And if you're not understanding what I've done over here, it's fine. I'm going to show you step by step how you can get this kind of a graph over here. So the first thing is, what is my y maximum? My cos x is going to be maximum no matter whatever is the input at 1. My y minimum will be at -1. I mean, sorry, of course, there is also a +1. I forgot about that. So 1 plus 1 is equal to 2. Your y minimum, what is your y minimum? Your y minimum is -1 plus 1, which is 0. So of course, your y middle is at 1. And what is happening? 0 degrees is going to be changed to what? The entire shift is to the right side of plus pi by 4. If you are aware about the transformations of x-axis, it is always the opposite sign of what is written over here. So it's x plus pi by 4. So what is 0 plus pi by 4? Of course, pi by 4. Now pi by 4 is a starting value. So the cos x will start from the maximum value because the cos is having a positive coefficient. So it will start at pi by 4 instead of 0. Okay, because the starting value is now pi by 4, not 0. And then I know that 90 degrees, that is pi by 2, is now changed to what? If I check my calci, what is 1 by 2 plus 1 by 4? That comes out to be 3 pi by 4. Okay, so now pi by 2 will change to 3 pi by 4 after doing x plus pi by 4. Okay, again, this kind of graph is very rarely asked, but yeah, you should be aware about how to draw it. So that is why I'm giving you the practice over here. Now you just do the 3 pi by 4 minus pi by 4. It will come out, the fixed interval will come out as pi by 2. So if I just go ahead and check, uh, 3 pi minus pi is 2 pi, 2 pi by 4 is pi by 2. So yeah, fixed interval is pi by 2. You are going to start your value at pi by 4. So after pi by 4 plus pi by 2 plus pi by 2 plus pi by 2. That is the thing that you're going to keep in mind. And 0 to 2 pi. The minimum is at 0, so I can directly draw a graph like this over here. So first value is at pi by 4. So what is pi by 4 plus pi by 2? Let me check. Of course, you are not able to see it. You can do it along with me if you like. So the answer comes out as 3 pi by 4. And then if I do plus pi by 2, it is 5 pi by 4. And then plus pi by 2 is 7 pi by 4. Now 2 pi value is what? Let me check. 2 pi value is coming out as 6.283. So what is 7 by 4? 7 by 4 is 1.75 pi. So it's still less than 2 pi. So I just need to add 7 pi by 4 plus pi by 2, and I guess that will be the final value. 7 pi by 4 plus pi by 2 is coming out as 9 pi by 4, which is greater than 6 point something. So it's greater than 2 pi. So 9 pi by 4, I'll just write it over here. And now the graph is going to start at the maximum value at pi by 4. The maximum value is at 2. The middle value is at 1. Dot, 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 dot. So at pi by 4, you're going to have maximum. At 3 pi by 4, it will be middle. At 5 pi by 4, it will be minimum. At 7 pi by 4, it will be over here. And now you can just complete your graph. Okay, you can just simply complete your graph. Let me do it. And then I can just find the value that what is at 2 pi, what is the value, and at 0, what is the value. I can simply use my CAIE and I can find that. So yeah, this kind of complicated graphs you can't really see in your examinations, but if it comes, you should be aware about how to do it. Okay, so that is why I'm doing it for you over here. And it is 1.707 at 0. So 1.7 is somewhere over here, right? So yeah, I'm just finding that value in the CAIE. And 2 pi will be somewhere in middle of 9 pi by 4 and 7 pi by 4. So of course the graph will go, I guess the value will be at the same value. So if I just write it in my CAIE, I'm getting the same value, yes. So it will just go to that. That's it. That is your complete graph. Okay. It is not going till 2. It is going only till this point, which is 2 plus root 2 by 2. I've used my CAIE to find cos of 0 minus pi by 4 plus 1 and cos of 2 pi minus pi by 4 plus 1. And both of them comes out to be 2 plus root 2 by 2. But yeah, if you had to draw the graph, that is the graph. And of course, what is the range? The range is going from 0 to 2, right? From minimum to maximum, because one complete graph or one complete cycle is visible to you. So I can just write that my range over here is from 0 all the way up to 2. The chances for this type of questions is very rare that it can be there in your final examination, but just wanted to give you a practice at least once. Okay, just like this kind of question is very rare that you can get a reflection in the x-axis. Just like that, this question is also very rare. But yeah, you can keep on practicing questions like this by yourself. And if you are getting stuck, feel free to leave a comment and I'll get back to you as soon as possible. So over here, I'll change it now. So it is 2 cos of x minus pi by 4 plus 1, and the domain was 0 to 2 pi. And that is how the graph is going to look like. You can see 2.412 is there. I hope I have not messed it up over here. Oh yeah, I've written a 2. That is why. Okay, yeah. Now you can see that it's 2 plus root 2 by 2. That is 1.707. And the graph is exactly what we had got over here. See, same graph. So yes, this was the practice with respect to the cos graph and the sine graph. For the tan graph, it is slightly different than what I have taught you for the sine and cos. But regardless of that, even that is easy. But one important thing that I'd like you to do as a part of the practice, please use Desmos, create your own questions, and keep on solving until you are 100% confident. Okay. Now, finally, moving on towards the 10 graph. In 10 graph, either your graph is going to look like this, that is increasing, or it is going to be decreasing like this shape. And the graph always goes from negative infinity to positive infinity. There is no stop. Like in the sine and the cos graph, we know that the maximum value was 1, minimum value was -1. In 10x graph, we don't have something like this. The fixed interval of 90 degrees over here, what does that mean? That after every 90 degrees, either you will get a 0 or an asymptote, 0 or an asymptote, 0 or an asymptote on the y. Like this is your y value of 0, y value of 0, y value of 0. And then this is your x asymptote, 1, x asymptote 2, x asymptote 3. And like this on the left side also you can keep on having this kind of things. So first asymptote is always at 90 degrees. Then keep on adding 180 to it. 90 plus 180, whatever is the answer. Or in simple words, the fixed interval of 90 degrees just means this only. After 90, 180 is 0. After 180, if you do plus 90, that is 270. That is asymptote. Then 360, 0. Then add plus 90 degrees, I think it is 450 degrees. That is an asymptote. So after every 90 degrees, you will see this kind of a pattern. Y is 0, then there is an asymptote. Y is 0, then there is an asymptote. What is the meaning of asymptote? I've already cleared that to you in your previous video on the reciprocal graph. That the graph over here is either going to be like this between the asymptotes. If the value of the input of x becomes very close to, let's say, 90 on either of the sides, let's say 90.00005, that is, you are slightly to the right side of the 90, you will get a very negative value if you check your calc. And if you do let's say 89.99999, you will get a very maximum positive value for the 10x graph. So that is why you are having an asymptotes. And yeah, if you are not clear about the idea of asymptotes, you can watch the previous video of the reciprocal graphs and come back to this part of the video. But yes, this is what we are going to learn in this part of the video, that is in the 10x graph. I have hardly seen any questions on the sketching of the 10x graph. But let's say if you are supposed to sketch the graph or maybe find the range, how you can do it. And for that, first of all, I'm just going to show you how the sketch of 10x graph is going to look like. So I have to draw it in between minus 360 to 360 degrees. And I just draw something like this over here for the axis part. Again, a rough graph is going to do. You don't need to be very punctual about everything. And over here, we are having 0. After 0, we are having 90 degrees, then 180 degrees, then 270 degrees, and at the end 360 degrees. The same thing on the left hand side, minus 90, minus 180, minus 270, and minus 360. The first asymptote you can draw at 90 degrees always, if it's a normal x. If it's not a normal x, if you have to do the transformation in the x-axis, that kind of thing also I'll show it to you in a while. And after that, there is a 0, then an asymptote, 0 asymptote, 0 asymptote, like that it will keep on going. So 0 asymptote, then 0, then after before asymptote also there is a 0, then an asymptote over here, 0 asymptote, 0. And because it's a positive coefficient, so the graph is going to be increasing. For the negative coefficient, the graph is decreasing. So in this case, the graph is going to look like this. Start from the bottom and just create a graph like this. And then this pattern is going to be continued. Okay, this pattern is going to be continued. That's it. That is the beautiful way to draw your 10x graph. You don't have to be exact as I mentioned. It's just to get an idea of what you are doing. That's it. Because you want to find the range at the end of the day, right? Using the sketches. But this is the complete sketch. So after 360, it will go till the asymptote over here. Of course, the graph is coming like this, but because the domain is restricted to 360 degrees, so it's going to be something like this. Yep. And over here, you can't go beyond 360 degrees, or else the graph would have continued like that. But this is the complete graph. Now let's say we have to find the range. Clearly, we can see that the y values are going from negative infinity to positive infinity. So the range is all real possible numbers. That will be your range. But the question was just about sketching, so that is how you do it. But now let me show you a question where you are supposed to find the range of the 10x graph. So for the next question, we are supposed to find the range in this interval for the function 10 of 2x plus 1. Now for this kind of graph, you need to understand there is a changes in the x-axis. All the values are having a stretch factor of half. So 0 is going to become 0. So this is your starting value. And then pi by 2 is now changing to pi by 4, which is your first asymptote. And if you do pi by 4 minus 0, you can see that the fixed interval is pi by 4. And whenever you are drawing the graph of the 10x, it is now shifted up by 1 unit. So you can just draw a dotted line for the new graph that I'm about to show you. And the graph is just going to look like this. Instead of passing from 0 on your x-axis, it is now going to have, it's going to pass at y is equal to 1. Okay, that is the idea. So if I just go ahead and sketch the graph over here for this question, how is it going to look like? So pi by 2 to pi by 2 is the maximum thing that I can go to. So after pi by 4, if I add pi by 4, it will be pi by 2. Okay, so I've got the idea. Let's try it. So this is my 0, then a pi by 4. This is pi by 4. Then there is a pi by 2 over here. And then there is a minus pi by 4. It should be slightly closer. It should have the same difference approximately. And then a minus pi by 2 over here. This is minus pi by 4. Now the graph, as you know, is going to go from asymptote to asymptote, and because it's a positive 10x, it will be an increasing graph. So the graph, as you can see, goes from negative infinity to positive infinity, and for here it's going to look like this, and for here it's going to look like this. One change, I need to shift the entire graph up by 1 unit, so I'll just know that I'll have to draw a dotted line over here to show that this is my 1. So if I have to now sketch my graph, it's going to be like this. I hope it is making sense to you. Like this. Okay. Of course, I can say that the range is going from minus infinity to plus infinity. So range belongs to all real numbers. F of x belongs to all real numbers. That is your answer. There is not a single value in the output which you can't get. That is the main thing. So yeah, if I go ahead and just plot this part of the graph in between minus pi by 2 to pi by 2, and I have to draw 10 2x plus 1, 10 2x plus 1. So here is the graph. As you can see, I can also draw the asymptote. X equals to minus pi by 4 was the first asymptote, and x equal to pi by 4 was the second asymptote. So yeah, the graph is now a little bit stretched. I'll just refresh the entire screen so that it looks better now. Yeah, this looks better, right? X equal to pi by 4, x equal to minus pi by 4. And yeah, this is what the graph we had got over here. You can see it. It's exactly like that. It goes till pi by 2 over here, and this value is at 1. So let me draw y is equal to 1 also with a dotted line to replicate the graph. Uh, Sorry, I just need to copy this part of the graph and paste it over here. And this is now a dotted line. Yeah. So yeah, that is what we had got. See? And you can see that all the output goes from minus infinity to the positive infinity. So the range belongs to the real numbers. So yeah, the main motive was just to show you how to sketch the graph for the 10x, even with this kind of weird complications. And now we are having the final question with us, where we have to find the range for 0 to pi by 2 domain for the function minus of 10x minus 1. So over here, I can simply go ahead and understand there is no change in the x values because there is no transformation of the x values. So I can directly draw my x-axis over here. I can draw my y-axis. And because I just have to go from 0 to pi by 2, let's say this is my 0, this is my pi by 2, and this is my asymptote. Let me draw asymptote with a different color. And of course, my another asymptote tot was at minus pi by 2. And the graph of 10x is coming downwards because of the negative coefficient of the 10x. My graph is going to be like this, not like this. And the graph is overall shifted 1 unit downwards. So this is at minus 1. This line is minus 1. So instead of passing from 0, it will now pass at minus 1. So the graph that I'm concerned with is only this part. Only this part. Graph is coming from the top, it's cutting this thing and then going forever down like this. It's going to be like this, right? It's so weird, but yeah, I hope you got the idea. Main idea is just to understand that the minimum value is minus infinity, the maximum value is minus 1. So what will be the range in this case? So the range in this case is not minus infinity to infinity, but everything that is below minus 1. So f of x is less than minus 1. Is minus 1 included? Yes, because x equal to 0 was part of the graph on which we got minus 1. So less than equal to minus 1. And one mistake that I've identified in the question is x equal to pi by 2, it can never take. So the equal to sign over here should not be there in the domain. It should just be less than, just like what I've written over here, right? At pi by 2, of course, in this case, pi by 2 is giving the value because of the 2x. So even if though we had equal to signs over here, that wouldn't be a issue. Even if it's not there, it's still fine because I can see that even at pi by 2 and minus pi by 2, we might not get this value at the output over here, but we are getting 1 as the part of the output for x equal to 0. So still y equal to 1 is part of the range, and that is why we are not excluding any values from the range over here. We are not saying that everything in the real value except 1. We are not doing this because 1 is still part of the range because when x was 0, y was 1. But regardless of that, this is the answer that we have got for this question. And now it's time to check it. So 0 to pi by 2 is the new domain. I'm just going to copy it and paste it over here. This value is minus 1. The domain is having only one asymptote pi by 2, and this is minus 10x minus 1. So you can see that the graph is starting from minus 1 and then it's just going downwards till infinity, right? So yeah, the graph is going all the way below minus 1 till infinity. So that becomes your range. Okay. So yes, guys, that is how you can deal with the 10x graphs. And if I haven't yet showed it to you how the 10x looks like, that is how the 10x looks like. It is a continuous series of zeros, then asymptote, 0, asymptote, 0, asymptote, like that. And then you go from asymptote to asymptote. If it's a plus 10x, you go from bottom to top. If it's a negative 10x, you go from top to bottom. You go from top to bottom, from asymptote to asymptote, asymptote to asymptote. That's it. And then if there is a plus or minus shift, you can do plus or minus accordingly. Okay. So I hope that this has given you an idea on how you can find the range of the trigonometric graphs. A quick recap for the sine and the cos in 99% of the questions. If you just find out what is the new maximum and the minimum value, the range will go from the minimum to the maximum value, given that uh, your domain contains at least one single wave or one complete cycle. If it's not the case, in that case, you will have to sketch the graph. And whenever you are confused, you always sketch the graph. It will hardly take 2 to 3 minutes at maximum at the starting of your practice. And once you are having a consistent practice, under a minute, you will be able to sketch the graphs and you will be able to find the ranges. And for the 10x, the idea is pretty simple. You just understand where are your asymptotes. If there is a transformation in the x-axis, do the transformations and understand where is your first asymptote, then where is your 0, and then what is the fixed interval. Based upon that, you can draw your 0 interval. I mean 0 asymptote, 0 asymptote. And then if there is a plus minus translation in the x-axis, I mean y-axis, you can shift the graph up or down by the respective units. And that is how you deal with the 10x. So that's it for this video. Please go ahead and practice your questions from the Desmos. Make your own question and practice it from the Desmos. In the upcoming videos, I'll also solve questions from the past papers, including all the different kind of functions that we have learned. So yeah, make sure that you are watching that video. I'll include the trigonometry questions over there. I'll include the questions from the composite functions, how to find range of the composite functions, if there is a trigonometry questions over there, or let's say a reciprocal questions over there, how we can solve all these kind of things in the examination scenario. All of that is coming up in the playlist. So yeah, stay tuned for that. So with these things being said, thank you so much guys for watching the video so far. And if it is useful for you, I am 100% sure it will be useful for your friends also. So if you know any of your friends who are struggling with the trigonometric graphs or finding the range for the trigonometric functions, please feel free to share this video with them. That will mean a lot to me as well. Thank you so much, guys.